question this morning on my commute. So the PowerPoints, the notes, the Excel spreadsheets, I've got a bazillion things that I end up using in the class for references. I'm not one of those guys who just writes on the board. So I try to mix it up though to keep you guys engaged. But the problem with it is, because I have so much stuff, hyperlinking it each day becomes troublesome for you guys and also for me to remember to do it. So what I'm going to do, if you look at, let me just go through here real quick. If you go to the schedule page, let's fire it up real quick, and you look at Monday's day, if I hit enter, that might work. So you go to Monday's day, right here, it says went over an introduction to problem stat. You click on that, that's the PowerPoint we did in class. Okay? And then it says started measures of censure. If you click on that, that's the notes that I was working off of in class on Monday, loosely. I mean, I kind of loosely follow this, but what I'm going to do is, on Friday, I'm going to create a separate page, like the schedule page, but it'll have each topic with all the resources I use in each topic, the PowerPoints, notes, Excel spreadsheets, all the shebangs. And then what I'll do is I'll just when I say went over, and you know what I might do? I might just make it an extension of this, so that the homework is with everything else. So like that first block will just be intro to province stat, here's the homework sheet, here's the PowerPoint, here's the notes, here's the, and just keep it all in one place. That makes more sense. With less pages, fewer pages. Yeah, I think that's a great idea. Yeah. So Shireen, thank you. I'm going to fix it. It won't be till Friday though, because I need like 4 hours instead of just collect it all in one place. Yeah. But you can at least, but you can always remember on the schedule page, within a day I'll have the videos linked up. And then you jump from there, it takes you out to YouTube, and then that's the beginning of the free show.
I must have just all of them except for that one.
So, yeah, cool. And I'll have it soon for you.
All right.
And we'll go through it today for sure. So thank you for asking, and we're going to get it. It's part of the. It's just like the internet itself, how it's become this ungodly mess of information that's really kind of hard to categorize and organize. I've been doing this for almost 20 years now. As things go, you keep adding more, refining, but keeping it updated in all the places is next to impossible. So what I'm trying to do is actually simplify it so it's in one place. And I just made an edit today, which I'll have to then edit again on the FileZilla server. So it's just, it's me. But anyway, I'll figure it out, make it clean for you guys to find. You don't have to worry about searching the high and low to find it. But please.
Have we talked about the project yet?
We have not.
Can we talk about that? Because it says
sure, do next
on
week.
The project and.
Oh, it's down here.
Yeah, what is that?
It's week 3. It's right here.
Oh, okay.
Yep, it's already. Amy, hello. But it's basically a self-guided thing. Think of it as a quiz, a little bit longer quiz, if you will. It's one of those things that's worth 25 points. So you got one in week 3, one in week 6, and I pretty much just put that out as a reminder because you have so much to turn in this class. If you have a day without homework, just start getting on the other stuff. You know, I mean, it's not due for a week and a half out. But you know, why not just get started? Is anybody getting it? I think Stacy, you said you got to start on it, and it's reasonable.
Yeah.
Yeah, reasonable. I think Stacy was concerned because the math is so minimal on it, i.e. there is hardly any. It's simply percentages and interpretation of percentages. Kind of like your quiz you turned in today. Ish. So, how are the quizzes? Decent? Yeah. I see 2 pieces of paper. We did them both. Good. Easy. Good. Should be. The first one, just an arithmetic kind of review to make sure you can change percentages to decimals and things like that, and make sure you interpret them. And the other one was just the intro, you know, like the qualitative, quantitative, discrete. And the last one, I got a weird email from a student that said, the last one I said find some other malady, right? And I got an email, not from somebody in your class, the other 243 said, we can't get on the CDC website, they're shut down. I'm like, oh crap. And then I'm like, no, they're not shut down. There's a warning on the top that says we will not be updating anything anymore.
Right.
But you can still get into the sites that are there.
Yeah.
But then
it's a PDF file too.
Exactly, it's a PDF. Exactly. You can pop it right open.
Way to try things first.
Well, yeah, it's okay. It's easy to complain. But it did make me think about how far-reaching that shutdown could potentially be. What happened? The national parks are now closed?
Right.
Yeah? A bunch of climbers. I just got an email from Rock and Ice. I subscribed to that, and they sent an email blast out saying that climbers are getting arrested. Or fined, at least. I mean, not arrested, but fined. Because they're going into Yosemite to climb El Cap, and there's no YOSAR out there to pull them off if something happens. And they're like, screw you! And it's tough, because it's a national park. You know, our taxpayer dollars pay for it.
Yeah, come up here and get me.
Well, but that's the problem. As long as you don't get in trouble, that's fine. As soon as you get in trouble, then the interesting stuff happens.
So does that affect Crater Lake?
Yeah.
National Park.
Yeah.
Yeah, I guess I'm assuming you can't get into it right now. Yeah, I'm assuming you can't get into it.
There's a girl at REI that said last week that she had to change her plans
Because
she
Crater
had
Lake's
planned to go.
closed. And this is the thing, I wouldn't have even thought of that. I would have driven right down to it. Let's go to Crater Lake. What the hell is it closed?
Yeah.
How do you close a 6-foot diameter piece of water?
Yeah.
6 mile diameter, 6 foot, 6 mile diameter. My kidding fool. How dare you, man? So yeah, interesting. Just it's amazing how far-reaching it is. Things you don't think about, like if you need a passport. Sorry, because you're not gonna get a passport anytime soon. It's just like things like that, right?
I put something up on Facebook earlier this week. I was like, Pell Grants, does anybody know what's going on with those? So
No
those
idea.
are okay.
Oh, those are okay.
Yeah, those
okay.
are
Those are
okay.
okay. Yeah. It's tough to know. Sometimes it's tough to know whether something's federal or state or local. Sometimes that's tricky. So maybe hopefully they fix all this crap soon and we can get back to whatever life is like when the government's working. Is that any different? I don't know. I guess we get to the national parks and get our passport photos.
Yeah. Go back to Crater Lake.
That's go back to Crater Lake, exactly. It's funny, I tried to rent a room at the Crater Lake Lodge. Our anniversary was September 30th. I'm like, September 12th. I'm like, this will be great. I'll rent a room at Crater Lake Lodge. A year in advance, you got to do that at the lodge. I'm like, what do you mean you got no rooms? They're like, there's like 20 rooms. And people come from all over the world to be here. I'm like, oh, well then I'll do it now for 2014. And I did it before the government shut down, so yes.
I did that a couple of years ago. My old wedding anniversary was the 23rd.
Yes.
So just be forewarned that they are in the process of starting to close the lodge up because it closes like beginning of October.
Yep.
So they
September
started
30th.
running out of food. They had
Bring my
very
own.
few servers.
I'm a
Like
good fly fisherman.
yeah, it was like
Wife's a big
45 minutes before breakfast was served. Like from the time you sit
I'll
down.
pack in flour, I'll make my own pancakes.
Yeah, seriously.
I'm
Just
pretty
like
resourceful.
snacks. Yeah.
I'm a mountain man. No, I'm looking forward to it. I'm looking forward to the 10 feet of snow per day that Crater Lake gets, because it's ludicrous how much snow. You guys have been there in July?
I am.
Yeah.
In July, there are walls of snow on the road sometimes. It's crazy.
Wow.
And gorgeous. I mean, it's amazing, pristine body of water. I remember the first time I saw it, it's like one of those typical, like, oh yeah, it took your breath away. It literally did. Like, you come up that road, and you look over, you're like, oh God, that is 6 miles across. And you can't, it's hard to imagine what 6 miles looks like until you look down at Crater Lake, and you're like, yeah, imagine being the first human being to see that.
It's basically like San Francisco in a hole.
Is that really how big, like downtown San Fran is?
No, San Francisco is 6.5 miles across. The
6
whole
miles.
thing.
Just put it in Crater Lake.
Yeah.
Good Lord. See, that blows my mind.
You wouldn't even see it because it's so deep.
Yeah, you just fit in. The Transamerica Pyramid, you wouldn't. It's 2,000 feet deep in the deepest part, isn't it?
Yeah.
1,900 feet or something like that?
Yeah.
I had the kids in my 105 class estimate how much water is in Crater Lake, just to get some guesses. And I said, what do you think? Is it a million, billion, trillion, quadrillion? And then I had them do some rough calculations. And I don't know what the true answer is, nobody else does either, because who the hell measures it? But we guessed somewhere around 5 trillion gallons of water. Which is just, remember that image of $1 trillion?
Yeah.
I mean, imagine a gallon of water being one of those $100 bills.
Wow.
And then imagine 5 trillion of those, which would have been, I mean, it's kind of staggering to think about the size of that. So, a lot of water.
Yeah.
A lot of water. And cold. Anybody ever swim in it? It's phenomenal. Yeah. Cold as hell in the dead heat of summer. Because that kind of water doesn't heat up very quickly. Yeah.
Just
There's a
looking
great
at it.
jumping rock. If you go down the boat path,
Uh-huh.
not Wizard Island. I want to swim out to it, but I haven't quite gotten the nerve up to like step in the water and swim across. It looks so close. I'm like, I could swim across that. And then I'm like, maybe I could. But there's a rock. If you walk down the boat path that goes down, there's a rock like 15 feet tall that you can climb the back of and jump off.
Oh, wow.
And just be prepared, because when you hit the water, your lungs will. And your heart will skip, and you'll come off the air, and your lungs will explode, and it's pretty amazing. Yeah, I remember that. I remember that. Anyway, welcome to our government. Yes, trust that he did this. Yeah, he did this. Okay, so where were we on? We talked about quizzes, talked about projects. Hopefully, we got your project question answered, Madeline.
Yes, sir. Thank you.
Awesome. Thank you. Let me give you this too while we're at it. Just grab one of these. This is a data sheet. It's just got a bunch of data that we're going to play with in class starting maybe today, if not today, on Monday. Grab one of those, hand them around. Remember extras, work back up. it saves you guys from writing data down all the time. It's just a nice data set to operate off of. So last time we went over some questions, and again, I appreciate all the input you guys gave about the open source text. We're going to make it better as we go, so I appreciate you being part of that process. And I apologize for the guinea pigs in the process, but I think it works out best for everybody. I'm going to start recording videos Friday for the open source. So I'm going to go back to that first homework set, and whatever doesn't have solutions, I'm going to record video solutions to and post on YouTube. I'll have those linked off the homework pages as well. That's my Friday morning. I'm totally stoked about that, actually. Just have to see those pictures. Poor students. So that's Friday, and then we were kind of in the middle, I think, of dealing with this last time. Yeah, we were trying to figure out some data about our keys, and we had gone through. Oh, thank you. So Christina, let me see how much throw we got. I want to go this way a little bit. No, yeah. Just do this. Just do this. So, number of keys. And we had started a chart yesterday. We didn't finish it. That's okay. I wanted to finish it today with you guys. We were talking about raw data and also grouped data. Okay, we made a little chart. And we had an average, a median, and a mode, which needs a bigger box apparently. So we got an X bar, we got a median, and we've got a mode. And let me back out right quick. And I know, I apologize, Stacy caught this right away that I had the wrong class's keys up here, but I think we're using this one, right?
Yeah.
We're using this data set. And the other class was pissed too. You had their keys. Actually, they didn't work. I didn't even notice. But I told them. Then they were pissed. So anyway, here's our data. Remind me of the values that we got for the average, the median, and the mode, and we'll just slap them into the. We had a mode, right?
Yes.
Mode is
Mode is
It was 5. Right? There's a bunch of 5s. It's got to be 5, right? Good. Just a FYI, some data sets can be bimodal, trimodal, multimodal. They can have more than one mode. Some statisticians would actually call that data set potentially bimodal because there are also a lot of 4s. I don't want you guys as beginning stat students to worry about how much is enough to be considered enough to be bimodal. So let's have an agreement right now for modes. It's only bimodal if you have exactly the same number of times of the occurrence. And that actually happened in the Tuesday-Thursday class, which is actually your keys. So if you look at this one, they had 1, 2, 3, 4, 5, 6, 7 4s, and 1, 2, 3, 4, 5, 6, 7 2s. So let's call that, for us, our sake, bimodal, is if they have the exact same number of frequency of occurrence. If you have like a bunch of 5s and like 2/3 as many 4s, just call it the 5s as a mode. Is that fair?
Yeah.
It makes part of this class that is so gray a little more black and white, a little more obvious. So, cool?
Yes.
Awesome, fantastic. So our mode was 5. How about a median?
4.5.
We called it 4.5, didn't we?
Yeah.
That was beautiful. And remind me why it was 4.5. There is no 4.5 data point up there.
Between 4 and 5.
Help me out. Is it Andrea?
Andrea?
Andrea, yes. Go ahead, my friend.
It was between 4 and 5.
Good. And why did we go between 4 and 5?
Because we're counting from both ends, so it has to be in the middle.
Excellent. If we count in, we end up chopping the 4 and chopping the 5. Those are the middle values, but then we can't chop them both. But we also can't have them both, so we go halfway between. Yeah, there we go. Beautiful. 4.5. And the average, we had to sum it all up and then divide by 32. What did it sum to?
130.
130? Beautiful. Divided by 32, which came out to be ish.
4-ish.
4-ish. It was 3. Yeah, good. We'll call it 4.0 something. Call it 4-ish.
Sure.
Yeah. Good. Sounds good to me. Awesome. And then that's as far as we go with the raw. And that's what I wanted to do because I wanted to deal with data as it's often given to you. This is fantastic. When you have raw data, the problem is very often you don't get raw data given to you in visual displays. It's given to you in histograms, it's given to you in Pareto's, it's given to you in lots of other ways. So let me just, this is what we were playing with at the very end of class. This is the same data, but it's grouped up in classes of width 3. 0, 1, 2, 3, 4, 5, 6, 7, 8. I know it seems kind of ridiculous to have it go out this far. The reason I did that is because I keep track of historical data too. And actually I had one class 1 year where a kid had 29 keys in his pocket.
Was he a janitor?
I don't know. Never asked him. I was like 29. Really? And he held them up and dropped them, and you could feel it in front of the room when they hit the ground. So you can see the lion's share of where the data occurs is down here, like it did for you guys. But then we do get occasionally over time these beautiful skew.
Outliers.
Outliers. Very nice. Very nice. So here's us. Here's us. Didn't trim it off though. So I think we pulled one of those three values from this chart. Yeah.
Yes.
Was it the mode we pulled? Good. And what did we decide the mode was?
He said 3 to 5 or 4.
I didn't say that, you guys did. It was beautiful.
Or-
I disagree with you.
Right.
Yeah, 3 to 5 or 4. If you need a single value, you have to pull a value out of the chart. So you're going to call it 4. 3 to 5 is also fine, but if you want to go with a single value, you just call it 4. Notice 3 to 5 includes the 5 that's over here, the true value of the mode. So you didn't lose very much by going to a distribution, which was a concern, if I remember correctly. We were concerned about that, weren't we? We said, oh, as soon as you go from raw data to grouped, and Stacey, I think you brought it up, and somebody brought it up, you said, wait, it's not exact anymore. Because you don't know what each of the individual data points are. Like, you know there are 7 zeros to 2s, but you don't know if they're all zeros, if they're all 2s, if they're evenly split. You have no idea what they are. So that's challenging. It's challenging to deal with, but let's just put our minds at ease right now. How about a median? Did we do a median or we
Yes,
did?
we did.
We
Four
did.
also.
And we got a 4 for a median. And how do we do that with group data? Who remembers how we did it with group data?
Centered it.
This is John, right? We centered it. Tell me, explain
Yeah.
more.
So it's across the bottom, across the x-axis. We went to the 4 because that's dead center between all 3. Yes.
Oh, good.
Yeah, and then we came down to the center of that bar graph as well, and it gave us the exact median center.
Good, very good. John, can I ask you a question? I love that, by the way. This is pretty symmetric data. What if you had something like that? How could you find the median for, this is the historical values, how could you find the median on something like this? Where the graph isn't symmetric, is I guess what I'm getting at, where it's not mirrored. I open that question up for the whole class. How could we find the median of this guy right here?
Number of bars.
Go with that, John, go with that.
What in the middle? We're looking at.
Where's the middle?
6 to 8, 9 to 11 in there.
6 to 8.
Well, okay, I didn't see that.
No, that's okay, bro. That's okay. This is the trick, right? The trick is this section is called measures of center, and I remember I put centered in quotes. I put center in quotes because center means different things depending on what you're talking about. The average center. Remember what average kind of in conversationally we were talking about? What kind of words were we using for average? For the arithmetic mean, for the add up and divide by n.
Shared.
Beautiful. Shared equally, something like that. Shared resources. You guys had some really good words for that. The other class said fair share. Love that too.
That's
Everybody gets the same thing.
Yeah.
Another one that is very, sometimes used, not often, but sometimes used is a balance point. If you had to put a balance point on the graph, the balance point would be where the average is, exactly. It actually exactly balances it. So the question of that would be where would the pointer go? Median is not always a balance point. Sometimes it is, sometimes it isn't. But it's always the geographic middle, like John said. So let me ask the question a different way.
Can we
Go ahead, Madeline, please.
just I don't know.
No, go.
Okay, so can we kind of like add up the occurrences of each
Yes.
of these groups and then figure it out that way?
Yes, which I think is what John's getting at. But it gets uglier with data sets like this. So let's just go back to our data set, which is a little prettier. So you see what Madeline said. She's like, there's 7 occurrences here of 0 to 2. There are 19 here, and there are 7 here. No, that's 6. So remember how we found the median? Andrea had me find the median of the raw data. She's like, count in from the ends until you get to the 16th and 17th ones, and it's between the 16th and 17th. Do the same thing here. There are 7 here, correct?
Mm-hmm.
And there are 6 here.
Mm-hmm.
So throw those away because they're the outside. They're the extreme values of the data set. So that's the same thing as counting in from 0 and 8 and coming in this way.
Mm-hmm.
And get in until you've gotten to the 16th and 17th data points. And where are those 16th and 17th data points going to be?
3 to 5.
They're going to be somewhere inside this 3 to 5. You can think of it as a chop. Think of it this way. Look back to the raw. Oops, not too far. There we go. One way to find the median, I don't know if we did this in class, is to cross, 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 and keep doing that until only 2 numbers are left. And the 2 numbers are going to be that 4 and that 5. And halfway between those is going to be your median. Well, you can totally do that with this, right? You can cross, 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 and now there's 18 left that we haven't crossed off. You bring those down, and it really doesn't matter. They're somewhere in this bar, and that bar indicates 3 to 5, which we'll just call 4. Does that make sense? Is that believable and fair?
Yeah, can we look at the bigger one though and see?
Sure, absolutely. Andre, ask me that question.
But for 3 to 5,
Yes.
typically for those 18 numbers, it could be all 3s or it could all be 5.
Good. Could we go back to that question?
Yeah.
2.5 minutes, I promise you. Not a second more. It's a great question. It's a fantastic question. So Madeline's question is, how do we deal with this mess? Well, you do the same thing, but you have to keep track of more numbers. So you're exactly, Christina, you got it. You got to do. So cross the 1. I'm going to add up some of these small numbers. There's a 1 and a 4. That's 5. That's 15. I think it's 43. So that's 58. So now we've got 58 plus 154 is like 200-ish, 210.
212.
212.
Is it exactly 212?
It is exactly
Holy
212.
hell. 212 and 212. Chop! Median's in there.
Wow.
I wish I could say I planned that. I didn't. Thank you guys for contributing to that because you guys are in that data. But that's how you do it, exactly the same way. It's just a little more tedious.
Okay.
But now, some textbooks, of course, will have a formula for it. And they'll say, depending on which height you land in this bar, so for example, if we're chopping and it doesn't come up symmetric, suppose, for example, these numbers aren't there, and it's just these 2 bars. So you'll chop off all these and this much of this, and then you've got this left. They'll say, since there's so many in here, you should go to the higher number of this. It's complete and total hogwash, due to the answer we're about to have, Andrea, for you in about 1.5 minutes now. So just go with chop and get in the bar. And once you're in that middle bar, you're golden.
Okay.
Cool?
Great.
Great. So it's just more tedious for a bigger data set is all. Cool so far?
Yeah.
Good.
All right, and now, finally, we get to the average. It'll be more than 1.5 minutes. I apologize. There's some math to do for this one. What is the average here? What does your gut say it is, based off that bar?
4.
We say 4, right? Now, I also kind of gave the answer away by saying where you would balance the graph, right? You would balance it. So you'd have to balance it. I mean, there's a little bit more weight on this side than this side. So there's dead center, maybe a smidge to the left balanced. Maybe a smidge to the left. Where would it be on that nasty graph where the outliers are? So, would it be here?
No.
Maybe a smidge this way?
Yeah.
And the question then becomes is how far that way would it have to go? And you can estimate all day long. You can guess 4.5, you can guess 5, maybe 5.5. It all kind of depends on how far out that guy is, isn't it?
Yeah.
I mean, imagine, you're walking a tightrope, somebody puts a weight on the end of it, you have to move, or closer to it, yes, actually, closer to it to kind of balance that weight out. So there's a mathematical construct for calculating the average. And let's walk ourselves through it. So the other 2 are done just visually. As far as calculating this average, I'm going to have ink with this guy. As far as calculating this average, what I like to do is set up a little t-table. Okay, so this is average of grouped. And I'll turn the light back on in a second. I know this is kind of hard to read. Let me get the data off of here, and then we'll cut the lights, or add the lights. Cut this guy. That'll be easier to see. So I like to start from a distribution. So start from the actual XF. So X and F. Okay, we'll use that as the middle line. The trick is X is a range of values 0 to 2. So what are you going to do with 0 to 2? You can't use 0 and 2 or 0-2. You have to call it one number.
How about 1?
How about 1? That's the most logical thing to call it. We'll come back. This is Andrea's question. Andrea's question I want to answer is why we use 1. We'll come back. So 1, 4, and 7. We're going to use those. Those are called, I think they're called class marks. I think. I could be wrong. Sometimes I am. But that's what you do. You pick the median or the middle of each of the classes. This goes back to our discussion in class on Monday about the classes that were not the same width. Remember that? With the estimation of the middle class income, how they were different widths? If they're different widths, you pick the middle of them. This is why I like having them the same width, because that way you get kind of a uniform spread. But if you don't have it, you don't have it. And I just realized the camera's pointing on the wrong side. Sorry, YouTube world. All right. Ooh, look at that today. Hello. Master swimming at 4 a.m. Or 5 a.m. Excuse me. And then we put the frequencies: 7, 19, and 6. There we go. And I think I can turn this off now for a moment. Turn the lights back on so it's easier to see. So essentially, that's what we've got. The question I have is, how do we turn that into a single number that is the average?
You multiply those across and then add that
Why would
up.
you do that? Madeline's got a vote. Her vote is to multiply the x's, excuse me as I belch, the x's and the f's. Why would you do that, Madeline?
Because then you come up with like a real number that you can divide by 3, I guess.
Okay, good. Let's come back to that. Let's start with one step at a time. Madeline's first idea is to come over here, create a column called xf, essentially, which is x times f. So she's saying 1 times 7 gives us 7. 4 times 9 gives us 70, is that 76? 7 times 6 is 42. Check my math on that. My math kind of sucks nowadays.
Yep, that's right.
Okay, Golden? All right. So, let me ask you a question before we go any further. What are these? What are these? 7, yeah, they're numbers. What's the unit on those numbers? Like 7 what? 76 what? 42 what?
Keys.
Tell me your name.
Joe.
Joe, thank you, friend. They're keys. This is keys right here, correct? X is number of keys. F is how many people had that many keys. So if 7 people had 1 key each, that's 7 keys for those 7 people. If 19 people had 4 keys each, that's 76 total keys for those 19 people. And if 6 people had 7 keys each, that's 42 total keys. So Madeline, the next thing you said, which I thought was pretty slick, was to add up that number, right?
Mm-hmm.
So just sum that up. Is it okay to put big sigma xf?
Sure.
What does big sigma mean again?
Sum.
Always means sum. Whenever you see that bad boy, it means sum. I like that symbol. It does save us some time. So we're going to add it up. We're going to get, what's this, 110, 118?
125.
125? What's that mean right there, 125?
Number of keys.
That's going to be the total number of keys in the class. Notice, the actual number of keys was 130. How did we do?
Pretty good.
Pretty damn good. Andrew, getting closer to answer your question. Now, that's the total number of keys. That doesn't give us the average. We got to turn it into an average, right?
3 sections.
So what are we going to do? Say that again.
3 sections.
3 sections, so divide that by 3. If I divide that by 3, though, I'm going to get an average of 40.
Divided by the total of the F's.
Christina, why would I do that?
Because that's.
Because you should do that. No, I will go back to what John said first. There are 3 sections, 3 classes. Boom, boom, boom.
40 keys per class.
40, on average, 40 keys per class, but I want to know what the average number of keys is per person in this room. So we've answered a different question by doing it that way, haven't we?
Oh, yeah.
So, in other words, think about the average formula in your head for a moment. We need to sum up all the keys, which Madeline's done for us. But we also need to sum up the sample, which I think Christina's done for us, hasn't she? But if we add up this bad boy right here, this number should look familiar to us, right?
32.
Sum of F is 32. Sound familiar?
Average people.
Nope. Mm-hmm. That 32 is the same 32 we had over there. Which means I think we got ourselves an average now, don't we? I think we got ourselves an average. If I swing back over here, as far as the group average goes, give myself a little more room. This average right here, this X bar average, we're going to do with the sum, Madeline's XF sum divided by Christina's F sum, which I know looks terrible, but honestly, all that is what you did over here. But you did it in the way that you could do it with the data in the presentation that we had. So you end up with 125 over the 32, correct? Which comes out to be 3.9-ish, which rounds to 4, and the other one was 4.0 something, which rounds down to 4. So in other words, we're off by 1/10 by getting grouped data. So I promised Andre an answer in 2.5 minutes. It took more like 6. But should we be concerned when we have grouped data that we're not going to get close to the average?
Apparently not.
No. This is anecdotal evidence, of course. This is one occurrence. But I tell you this, I've run this thing for 15 years, 4 or 5 times a year. We always get within no more than 2 or 3 tenths away from the true average of keys from raw. This is Sherry, and she's over here. Sherry, why you going?
No, I just don't like it. I like
Well,
precise
now hang on now, hang on now. Hang on now. I do too. I do too. If you're talking about like a drug dosage, I'm not saying this is the way to go. You could kill somebody with this. Vicodin, give him 5. Don't you mean 0.5? No, I mean 5. You like me, decimal point. I'll tell you, 6 or 60 feet. I mean, there's a time when orders of magnitude are important. But here's the question though, Sherry, the concern. If you don't get the raw data, can you still get an average estimate from it? And the answer is yes, you can. Now finally, Andrea's question. The reason is, let me go back to the graphic, which will help us. Do I need this down? Finally, to answer your question, which is such a good one, I want to make sure we answer it properly. How's that look in that screen? Is that okay? In the camera screen? A little bit off? Let's play with that a little bit. Oh yes, there we go. Beautiful. Thank you, guys. Let's kill the light. Okay. The problem exists in, as Sherry pointed out, there are 7 items in this bar that are 0s or 1s or 2s. And when it's continuous data, it's even goofier because it could be between the 0s and the 1s. Like if it's a temperature, it's not just 0 to 2, it could be 1.5, 1.4. The question inevitably, as we brought up, was, are they all 2s? Are they all 0s? Are they all 1s? Are they evenly split? The assumption that this calculation is making is what? Can you tell what assumption the calculation is making?
That's an equal distribution?
Yes, perfect, Andrea, that it's an equal distribution.
Which is wrong, because it might not be.
It's wrong precisely, but on average it's correct enough. Check it out, check it out. And I didn't check this yet, let's take a look. There's your keys, okay? Here is 0 through 2. Check out the distribution. 2 0s, 3 1s, 2 2s. Not bad. Not bad, that's actually pretty much perfect. Okay, 3 through 5, right? Now check out 3 through 5. We're underestimated here. We've got a bunch of 4s and a bunch of 5s, so we're underestimated on the 3s. And then check out the 6 through 8, which is this, we're overestimated on the 6s and underestimated on the highs. You see what just happened there? In the second bar, we were underestimated in the second bar we were underestimated on the 3s, so we were overestimated by the numbers themselves. But in the third bar, we were underestimated on the 7s and 8s and overestimated on the 6s. So what happens over the entire data set? It evens out. And that's called the law of large numbers. Why is it called the law of large numbers? Damn if we can prove it. You can't prove that it's going to happen because you'd have to have every data set in existence to do it. But what's happened is most data sets that we get fall like that. I've never gotten a data set where everybody had either 2 or 5 or 8 or 11 keys in their pocket, which would of course totally skew the average, wouldn't it? Mm-hmm. If you guys were all on the top end of each of the data classes, the raw data average would be very, very high, and the grouped data average would be below it because you'd be underestimating it, assuming there are 4s when there's actually 5s. What happens in reality? This. Now here's the deal though, as Sherry pointed out, that's precision and accuracy. This is only accuracy. We have to sacrifice a little precision because we don't have the actual values. But anybody concerned? We're off by 1/10. I can live with that. Mm-hmm. And if this is all you've got, that's all you can possibly do. If you have access to the authors, this is, I bring this up mostly because some of you are sitting there going, why don't you just get the raw data? Right? Just get the raw data. And if you collect your own data, you can do that. I just did it in Math 105. I asked them a question. I said, on average, if I give you a coin, how many times do you have to flip the coin until you get each side at least one time?
Twice.
On average.
Oh, on average.
On average. So in other words, you could go heads, tails, 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 tails. And then you've gotten the heads and tails. Or you could go heads, 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 tails. You see what I'm saying? Mm-hmm. So you could get it twice. It might take you 13. So the question is on average. What I did was I gave them all a coin, and they groaned, oh God. And they started flipping. I'm like, this is kind of fun. Because it's statistics, of course it's fun. And then at the end of the day, I had this beautiful chart, which was the raw data. And we calculated the average. And guess what? The average they got was 2.95. Guess what the actual average is? 3. On average, it takes 3. Because for some reason, you expect a doubler in there somewhere. On average. It seems like heads, tails, you're done, right? Heads, tails, it's over. But it averages out to 3. Then I gave him a die. I said, if you roll a die, how many times on average do you have to roll until you get all the sides at least one time? Okay. And I had guesses everywhere from 6, somebody said 80, 18. Okay, what do you guys think? Rolling a die now. 6-sided coin, if you will. 18. 18, because 6 times 3 is 18. Good. Good, I like that. Good. Say 80 was one of the guesses. What do you guys think?
15.
15? 12? 20? Yeah, I mean, it's hard. So I gave them a die, I had them roll it. Collected all the data, calculated their average, they got 13.6. Guess what the average is? 13.7.
Oh, wow.
I was like, it's amazing. I shouldn't be surprised, but I was still like, I got like flustered. I got goosebumps. I'm like, I know it's gonna happen, but then it still surprises me. Like, I'm like that. What's that movie? 50 First Dates with 10-second Sam, whatever his name is. How you doing? My name's. That's like me with these experiments. I know it's gonna happen, and then I forget. Like moments before, I look at the result. The point is, unless you have the raw data. Unless you have the raw data, you have to accept some level of imprecision. Look at this, look at the level that we got. I mean, I'm pretty excited. Yeah. Cool? Fair? So you can deal with raw data, you can deal with group data. Now, you know it, being able to deal with it is one thing. But that's like putting you at the bottom of a rock climb with a bunch of quick draws, cams, tri-cams, stoppers, and slings. Got a couple climbers laughing in here and going, go up that crack. And then watching somebody 20 feet up in the air with a quick draw, trying to put a quick draw to a crack and trying to figure out why it's not working. So the question is, you have these tools, now which one do you use? And that's what I want to spend some time on right now. I want to spend some time on that right now. Okay, so here, that's supposed to be animated. Oh, because it's not on. Here we go. Beautiful. Here is a sample of adult men and their LDL readings. LDL is
Cholesterol.
cholesterol, what kind?
Low
The bad stuff, low density lipids. This is the bad cholesterol. This is where you want low numbers, LDLs. HDLs, you want high numbers.
Yeah.
How do you decrease your LDL numbers?
Stop eating right.
Exercise?
Lots of pizza, yes. Watching your diet, exercising, right? Taking care of your body. Smoking lots, yes, of course. Not smoking a whole lot. So LDL can be controlled. How do you up your HDL level?
Good.
As far as I can tell, it's very hard to do that. As all the research I've done is it's hard. Yeah, maybe. What is it, Walter? Walter, yes, it's hard to raise HDL?
Yeah.
Gotcha. I've read the same thing. It's extraordinarily hard because my HDL, I was a vegetarian for years, and my HDL was always pretty low, and the only thing that popped up incrementally was when I started eating fish and stuff again. Popped up a little bit, I guess because of the fish. Fish has good levels of cholesterol in eggs and things like that. But anyway, I think I'm going to tell you that today. This is a graph of men's LDL levels at a random sample of how many guys? How many? Very nice, Walter. Right up there, n equals 100. You can catch that. Look for that in graphs. Look for that in research. You'll see little things like margins of error and sample sizes. If I asked you what the modal LDL level was for these guys, what would you tell me?
4.75 to 6.25.
Sorry, I was taking a drink. I wasn't
No,
expecting that.
5.25.
You guys are good. The modal, and when I say modal, M-O-D-A-L, that just means the mode. What is the mode of these data? Christina, go ahead, I'm sorry.
It's a 4.75 to 5.25.
Why are you picking 4.75 to 5.25?
Because the most words has the most occurrences.
You got the most occurrences in 4.75 to 5.25. Exactly, I love that, I love that. So you can just say it's the entire range, or if you wanted to, just say it's
The most.
5. The mostest, that's absolutely true. The mostest. It's continuous data. You wouldn't know that unless you knew how cholesterol was taken. Cholesterol numbers are taken, they're measured. I think it's milligrams per deciliter, I believe is these numbers. So it's milligrams of cholesterol in a deciliter of blood. So both of those things are measured, so it's a continuous measurement. So that's why you see like 4.75 here and 4.75 there. You're probably not going to land exactly on 4.75. You're going to land on 4.79 or 4.749999 or 4.750001 or something like that. You're not going to land exactly. Good. Mode 5. I'll go with that. Median. How would you call the median of this bad boy?
4.75-ish.
Yeah? Would you pick a different value than the mode? I'm not saying that they necessarily have to be different. Would you just say it's also 4.75 to 5.25?
Yeah.
Yeah. Now let's think about why.
Cancel.
Actually, why?
Cancel everything.
Wait, do the cancellation like we did before. Madeline, you asked about that goofy curve before. Let's do some cancellations. chop that one with that one over there, yes?
Yeah.
Yeah, chop, chop. This chop with those two, but I think there's a couple more over there than there are here, yeah?
Yeah.
So we'll take a couple more off of this one. Now we're down to this bar, and this bar, yes? So let's chop all of this bar and all of this bar, but then we've chopped too much over here. So we'll take a little bit off the top here, but now we've got one bar left, don't we?
Yeah.
Everything's in here, so that means there's your median in that bar. 5, pull up 5. Fair? John, go.
Means there's more, it looks like there's more heavily weighted on the left. Wouldn't you take that to the left?
I love what you just
side
said,
of that,
brother.
instead of taking it off the top of the middle bar?
The median doesn't care. The median does not care. Did you hear what John just said? It's fantastic. Because you seem to have more weight on this bar than this bar, it seems unfair, if you will, to kind of assume you can chop this and this the same. The median doesn't care about the distances between data.
And then take it off the top of the middle one?
It doesn't, the median only cares about ranking, whether you're in the first place, the second place, the third place. So for example, the median would care in a foot race who came in first, second, or third. It wouldn't care if first place was Ashton Eaton setting the world record in the 400. Or if it was me setting no records in the 400, as long as I came in first place. Second place could be as close or as far away from first as could be, and it wouldn't care if it's just first and second.
Okay.
So the thing that cares about that isn't the median or the mode, it's the what? Average is the one that cares about it. Average is the one that cares about it. And that's where that kind of weighting, the individual data point weighting comes in. Median is simply an ordering, whereas average actually cares about the values themselves. Fair enough? Great question too, by the way. What would you call the average, friends? What do you think? 4.75? Yeah? Where would, think about it this way. If you had to balance that on a point, I'll start you going. You tell me where to stop. Is she here? Yeah. Pretty close to that bar, though.
Is that true?
Is what true?
I don't know that that's true, because that looks, 3.75 looks to be 7. 4.25 looks to be 27,
Mhm.
so that's 34.
Yes.
So over here, 5.25, that looks to be about
22?
22.
Yeah.
Plus 5 is 27, plus
Uh-huh.
4 is 31.
Uh-huh.
So they're really, really close. I don't know that it's pulling it that far over.
So Madeline, your vote is we don't have to stop even that far. We can keep going.
Yeah, like
Maybe-
right there.
Maybe to here?
Yeah.
So I'll tell you what, we can get a more exact value, which with methods we're going to learn momentarily using technology. I don't want you to do this by hand past the point. It gets ridiculous past the point.
But the number's the same. The bar on the left has this 4.75, as the bar in the middle has 4.75.
But wait, the bar on the left has 4 points.
The-
Oh,
the
careful,
top
careful.
and bottom
Continuous
range.
data. There are infinitely many data points between these.
Right, so if you stop in the middle, I mean, what are you even saying?
What do you, that's my fault for the graph then. I apologize. I shouldn't have space between the bars. The bars should be buttoned up next to each other. That's
Okay.
Bruce Emerson, if you're watching this, you were right again. Bruce always gives me crap about that. Whenever I do default Excel graphs like this, they default them to be gapped like that, and there really is no gap. There shouldn't be a gap. It should be buttoned up right next to each
Okay,
other. You're right, John. You're right. So technically speaking, we have to pick. We can't be right here. So we're going to go here, we're going to go here.
Right.
Right, as in literally go to the right? Yes, like over here. I think so too. Because if we go here, we're underestimating, I think. So I think we're in agreement it's over here.
Yeah.
Well, think about what we just did. We said the mode and the median and the average are all the same number. And that's the beauty of what's called symmetric and unimodal data. Symmetric, unimodal. Let's break down these definitions. I think we can define them verbally without having to write it down. Unimodal means,
One mode.
listen to that, one mode. That was solidarity right there. One mode for symmetric, or for unimodal data. What does symmetric mean?
Same on symmetrical.
Good. It means symmetric, damn it.
Same on both sides.
There we go. There's a mirror image reflection somewhere, basically right on the mode in this case, where you can fold over and fold back and call it good. So when you have that setup, what you often do, have maybe you heard of the bell curve or a bell curve? Yeah, that's symmetric unimodal. And by definition, that's kind of how it is. So when you have that, your mean, your median, your mode are all the same. So use whatever one you want to. It doesn't matter to me which one you use because they're all going to be the same value anyway. Let's take 5. I'm going to calculate this bad boy out to precision, to a tenth place during your break, and we'll come back and chit chat about it. All right, but take 5, yes? Take 5. Do I have anything to get back to you guys? I might.